This guy keeps taking pictures of me. Hi, everyone. I hope you had a nice, maybe it was an extra break. It's great to be back in Ukraine. We're not supposed to call it the Ukraine anymore. I don't know if people are hung up on that here, how you say Ukraine in English, but I'm trying really hard to say without the the. This is my third time here. In Ukraine, I just almost said the. Last time I was in Lviv, I was at a Pivorak kind of a conference thing. I don't know if people are most people familiar with Pivorak in Lviv? They're awesome, yeah? All right, we got some hardcore back there. They're great. Like, the community's great. The organizers are great. Their website is nuts. Like, I organize meetups, and my website is garbage, and theirs is beautiful. So if you ever get a chance to go over to Lviv, how do you say it? I feel like I'm saying it wrong, too. Lviv or Lviv? Okay. I guess I'm close. So, yeah, go there. It's great. So I'm going to take a minute to try and kind of get in the shoes of the audience really quick. This is actually a picture. This is what kind of as a speaker we always expect the audience to be like, but in reality it's more like this guy. So you heard that there was a RubyC conference coming, and maybe on Twitter or whatever, and you were like, let's find out what's going on. I'm going to go to the website. I'm going to check it out. And so you go to the website, and you're like, cool website. Let's find out who is speaking. Is it worth going to this year? I really liked it last year. How are the speakers this year? So you look at the speakers page, and you're like, oh, look. Oh, there's some great speakers coming. Look at these folks. Awesome. Katrina's going to be here. Wow. And then you see, oh, there's these dots down here. There must be more speakers coming. So you click on the second dot, and wow, more great speakers. It's amazing. You're looking through, you're reading the talks. It's great. Get to page 3, you're like, wow, this is going to be a great conference. And then you click the button one more time, and you see this disembodied head of a human being just floating in your face. And you probably were like, I have some questions about this talk, but you couldn't find this floating head anywhere to talk to, so you didn't ask me any questions. So this actually isn't the organizer's fault. They probably stole it directly from my website. So it actually doesn't say anything about being a developer here, and I'm not really a hiring consultant at the moment. It's kind of a lie. But yeah, that's, if you want to get in contact with me, just go to my website. It's my name, lastname.com. Yeah. So there are going to be, oh, holy shit. Okay, so I brought, and I forgot to bring down actually, some, maybe, you can do it for me. Can you do it? Can you do it for me? I have some treats. It's my secret hotel room number. It's in a little cloth bag. You know what they are, right? Yeah? The manna? Whatever, you'll find it. Go through my stuff. Go through my stuff. So I brought some treats for everyone. We're going to do some quizzes, and the person who guesses correctly, or if we have enough treats incorrectly, will get one of the treats that you'll see eventually. God, that's a bad move. So this talk is entitled Steal This Talk, which actually has nothing really to do with the content of the talk anymore. So I changed the name of it to The New Programming is a Managing, which is a joke that you'll get after the talk, but I thought I would front load it with a joke that you didn't understand. I don't know, it's kind of a stupid move, but let's see how that goes. I am from America. This is how we actually dress in America. Everything they told you is true. So, but for the last, I don't know, 12 years or something, maybe 10, I've been living in Europe, in Austria, and this is actually a picture of me when I was 3 or 2 or whatever age that is, and it's some foreshadowing of my future to come. People actually do wear lederhosen just around sometimes. It's awesome. Good friends of mine are just chilling in lederhosen sometimes. So I was living in 2013 I was living in a small town in southern Spain in the mountains, and there weren't any other nerds that I could find. I kept searching for nerds, and all I found was one guy who did medieval furniture. And that's a nerd, but it's kind of like from technology to medieval furniture, there's quite a span. So we couldn't really meet in the middle very much on that stuff. So I started going to conferences, and my first Ruby conference was Euruko in 2013. And I arrived at like 4 in the morning, and it was, I was tired. I had to stand through the whole first day because I would have fallen asleep otherwise, even though the talks were really fantastic. And I've been to a lot of Ruby conferences in between, and they're really my favorite kind of conferences I go to. The people are generally great, the organizers, the talks. Like I've been to other types of conferences, and just the talks are like, there's like half of them I really like, and then half of them I don't. But for most Ruby conferences, I'm pretty enthralled through most of the talks. So I decided that I wanted to travel around the world and speak at different conferences. So what I would do is I would start giving as many talks as I possibly could at meetups. So this is Vienna RB. I think I'm actually giving a talk sitting down in this picture. I've given probably 20, 30, maybe more talks. People in Vienna are probably completely tired of my talks, but I still kept giving them. And then eventually I got the urge, the guts to go out and start speaking at conferences and put out proposals, and people finally accepted them. And I got to live my dream of like hang out with nerds and going around the world, like in the Philippines with, if you've ever asked or looked for Rails questions, the second guy from the left is Simone, and he's pretty much always on Stack Overflow for answers to Rails questions. So I got to meet that guy who's just always in my Stack Overflow feed. And Mats is there, and we've got Konstantin Haza of Sinatra, and Nick of Trailblazer 1 and Trailblazer 2, and a bunch of other people there. I got to go to India and run my first 5K race on the side of a highway, which was interesting. And I went to Warsaw and actually hung out with the guy in the middle is the guy that just went up and got the treats that he hopefully finds. And here, the guy in the middle here, this is a castle in Austria, and the guy in the middle is a guy that wrote Everyday Things with Ruby and R, which if you haven't read it and you're interested in like kind of statistics and using Ruby to generate kind of experiments and stuff, it's working really great. You just missed your slide, Piotr. It's right here. I'll show it to you again. Yeah. So I got to go to Jakarta and eat durian, which tastes like the dead, and be in traffic, what they're kind of famous for. I got to use a toilet shower. Tel Aviv Beach, some of the best food in the world. I got to take a selfie, kind of a Instagram-level selfie of myself on the Burj Khalifa, the tallest building in the world. And the coolest thing that I've ever done, maybe in my life, was, I just have a bag of stuff now, is to do burpees on stage with Mats. And then later, with Koichi. And do people know what a burpee is? Yeah? Yeah? In case they don't know what a burpee is, does someone want to maybe show the crowd what a burpee is? No? Yeah? No? Yeah, I can do it. I don't do burpees alone, as you can see. So this is great. I was like, so let me take a little aside right now. So these are called Mana, and they're very Austrian. Any Austrian will tell you that they're very Austrian. It's a wafer bar. These are actually vegan, in case you're vegan. I think they're better than the non-vegan ones, or maybe they're all vegan. I don't know. They're full corn. They're whole wheat. But when we get to the quizzes, you'll start feeling that. Okay, so back to the talk. In 2018, I couldn't come up with talk ideas anymore. Something happened where I feel like I might have been doing interesting work, but I couldn't come up with a good topic. I gave some talks, but they were awful, and I felt depressed after I gave them. Just like I felt terrible. Like I'd go somewhere and just give a talk and then come back and just for a week like feel like crap. And I thought that might be the end of my dream, that it was over. And worst of all, I thought that it was possible that I might never get to do burpees with Mats again. And that was really the worst of everything. And then one day during my bout of depression, I was kind of looking through YouTube as one does, and I saw a video about an AI-generated rap. And I was like, that sounds interesting. How does that work? So this guy builds a recurrent neural network, and he feeds it with like all of the rap songs from some kind of a rap thesaurus or dictionary, and then trains the neural network and then generates raps. He does things, changes tempo. He finds downbeats and upbeats. There's a hype man, or like a hype person, or like a hype robot that kind of fills in behind the rap. And it's actually, there's certain times when the AI kind of is brilliant. It's very, very deep. At one point it says, remember the fam and carry the pain. And that's, I think, what the meaning of deep learning is. Good. It's good. I hope that one hits. So I had an idea, and I was like, oh, this is how I can solve my problem. I will create a recurrent neural network. I can't say neural for some reason, so it's a really great talk to give. I will create a recurrent neural network that can generate a talk title and generate a talk abstract and generate a description and a whole talk for me. That's going to be my goal. So I went with building a recurrent neural network to do it, and that brings us to our first quiz. So the way it works is I show you a list of things. You tell me which was generated by my neural network and which are actual talk titles from talks from conferences, Ruby conferences of the past. So here is the list. So should I read them out loud maybe? I don't know. What do people in the back, should I?
Do it.
Read it out loud? Okay, Ruby is the best JavaScript is number 1. Humans aren't APIs, and your request is 400 denied. Algorithms to live by and why we should care, and the impermanence of Ruby. Those are the guesses. The first hand that I see is there. You. 3. You're wrong. So which one was generated by an AI?
4.
I can't give these out to everyone. Who said 4 first? Who said me first? Okay, cool. So the impermanence of Ruby, that is doing this. Okay, you're welcome. So, so the thing that generated the text is a recurrent neural network, but I'd like to kind of explain how that works. And to start, I will start by explaining a convolutional neural network. I really have a hard time saying it. So what we want to build, this is a metaphor. We're going to work in metaphors a lot in this part of the talk, is a machine that can decide whether something is a windmill or not a windmill by you giving it an image. So if you are going to be giving talks at conferences, here is a pro tip for you. It's nice to kind of do things that are related to the group that you're talking to, but what it also means is when you decide you're in the Netherlands and you're going to do things with windmills, that you have to change a huge part of your talk if you go anywhere else. So maybe try to be generic, but we're going to go, I'm pretty lazy with this, so we're just going to go with windmills. So pretend there's lots of windmills in Ukraine. Maybe there are. Is that a fact? I don't know. So if we're gonna talk in this kind of metaphor world, one way to decide whether a picture is of a windmill or not a windmill is you could categorize kind of all of the things in the world, like all of the features of all of the things in the world. So I could look at a chair. I said it has legs, rectangle shape. It has a back on it. Person has a couple legs and a shirt and a head, some round thing, eye things, and some ears. And you could just do that with every object in the world. And then you could go, hey, this thing has a window. It has a trapezoid shape. It has these 4 rectangles that go off in this direction. It has kind of a cross shape. So it turns out that a windmill also has all of those features. So I'm 89% confident that this is a windmill. So that's just a random confidence level that I just put on a slide. So the problem with this is that it is incredibly efficient to take all of the things in the world, find every feature about them, and then create this huge list of all of the objects and all of their features. So, quiz 2. I think I only did 1 quiz or 2 quizzes last time. We have a lot of quizzes this time. So it might break up the talk in a way that makes it impossible to follow, but we're gonna try it anyway. So we're gonna do talk titles again. We have 1, the imposter approach. 2, pairing with Ruby. 3, debugging Rails itself. 4, reducing enumerable. So hands, which one? This hand in the front row is the one that I saw first. 2 is generated, correct. So it actually turns out that this one was kind of a trick because 2 of them are generated. Can anyone think of what the other generated one is? This isn't working. We have to kind of step back. Okay, I want to see hands. No yelling things out. Just because I was looking dead ahead. What? Which one? No. 3? No. What? Worst one? Yeah. Good job, man. You wanna? So I was kind of panting after my last run, so maybe people can come up at least halfway and meet me. Cool. Yeah, the imposter approach, which I think is an awesome talk name that I think that someone should give. Yeah. So that last way was incredibly inefficient. So what can we do to kind of make it a little bit better? What we would do, for example, with database tables is you would do something like normalizing the tables. So you would take all of these things that have things in common and kind of abstract those things away. So you could create kind of these machines that created categories. So one machine could be a machine that knew that this thing was rectangular, it had some boxes. This thing tells you whether something's a window or not. You have another machine that's like, if it has a window and it's a trapezoid shape, then maybe it's a building. So you're building these categories that you can put together. So the next one, you would have some blades. They have the cross through them. Cool. Great. This is a blades machine with the rectangles and the cross. Great. So then we take the windmill machine and we say, hey, a windmill is a building with blades. Cool. So we can have a confidence level that that thing is a windmill. So the windmill machine asks the window machine, actually asks the building machine, which asks the window machine and the trapezoid machine. They all come together, and then you have some sort of a confidence level that it's all put together. So this is also incredibly inefficient. You also have to categorize all the things in the world, get the features for them, and then find these categories yourself, which just doesn't make sense. There's always new things being created that you have to then add to your list. It sucks. So we're doing another quiz. I love quizzes. So I went through, there's that Twitter guy that always makes the fake, I had a bot look at 10,000 hours of Olive Garden commercials, and this is what it came. So I had a bot look at tons and tons of Reddit post titles from the Ruby subreddit, and this is what it came up with. So anyone, I'm looking for hands. Actually, sorry, that was too early, wasn't it? So I'm going to give you a second to read it, and then okay, now, anyone that has an idea. I saw someone, I need to not, I'm actually going to go to this side. I'm sorry, I haven't gone over here at all. Sorry, that side. The second one you think was generated by my neural network, correct? Number 4, you think number 4 was generated by it? You were also correct. Am I running out of these? I can only give this one because there might be more quizzes. Who said that? You? Okay, cool. So it turns out that the only real one here is number 3. So that was kind of a freebie for wafer bars for people. So yeah, emoji-driven development in Ruby was the only real one. Good stuff. Probably a really interesting article, actually. So the trick here is instead of going out and figuring out what these categories are yourself, you have the computer decide what the categories are. So it kind of picks categories at random, and then it combines things into these categories, and then it can make predictions about what the thing is in the end. So we're just going to kind of give an example of what one of the inputs to a neural network would look like. I'm going to simplify it. So we are going to take our windmill picture, and we're going to reduce it down to 32 pixels by 32 pixels. We're going to remove the color, which isn't really necessary. Maybe it simplifies it more. I think it does, actually. So for the example, we're going down to grayscale. And then we have essentially 1,024 nodes. So we have 32 times 32. We have a list of nodes. And each node has some sort of a value between 0 and 1 that is the grayscale of that node. So each neural network has an input node or an input layer, a bunch of like 0 to n hidden layers, which do kind of magical stuff in between, and then you have an output layer, which can either be one output or it can be multiple outputs. In our case, we only have one output because we want to know the percentage confidence that something is a windmill. So you would feed all these things. You would feed all those pixels into your neural network, and then it would flow through, going from node to node through the layers until it came out the other end of it with some sort of a confidence level. In our case, is it 87% again? Yeah, 87%, which is always what it is for all neural networks ever. So there's this idea of backpropagation, where the way that you train, the way that these categories kind of are brought together and strengthened is through the neural network having training data go through it, and then out the other side, it knows whether the data was correct or not, so it can feed the answers. I'm not describing this very well. It can look back and say, this pathway from the pathways that we just looked at, maybe this pathway brought us to a better solution. It was more correct, and this one wasn't. So through backpropagation, you can make these ties that were incorrect weaker and the ties that came to the correct answer stronger. So I'm going to go a little bit more into detail than that in a few minutes, but that's kind of the basic concept of it. And we have the kind of neural network that we're dealing with is we're predicting characters. So essentially the next character that comes in some sort of a line of characters to build words or symbols. We're not guessing the probability of something to be something or not. So we kind of need to use a different network model than this network model that I just described. So here is kind of a list of a bunch of different kinds of neural networks. One of the most basic ones is a perceptron, which say you have a history of things that have happened. You can look back and see, okay, I can draw a line through this scatter plot of things that happen, kind of through the middle, and that way I can look along the y-axis and see, okay, today, or this thing is happening today on the x-axis, so we can maybe predict where it might be on the y-axis. So it's essentially just like a graph where you have a y and an x-axis. And then you have things complicated like neural networks, or like the recurrent neural networks as well. So we just talked about convolutional neural networks. It's great for images, things like that. But then what we need to do for text generation is to use something called a recurrent neural network, where it's good for text recognition and voice and things like that. And the difference between the convolutional and the neural is memory. So there's state in a recurrent neural network. So for example, it would be really useful if you were trying to generate words, generate sentences, if you had the word good. If you pick the next word as food, it could make sense. I had some good food. You could pick run. I went on a good run. Those are possible sentence structures. But if you picked bad, there's pretty much no sentence that I can think of where good, bad would be in the sentence. So it's good to be able to look back a word, look back a character to make decisions about the next one, like vowels and consonants following each other. Which, of course, would be different for different languages. So memory is kind of the core concept of what makes a recurrent neural network different than a convolutional neural network. So one more. I took the Rails code base, and tried to print it out all into one file and then feed it into the network and then see what it came up with. The first results were not looking very promising. I have no idea what was happening here, but it just wasn't good. You can see a lot of text and a lot of the same number over and over again. It's kind of like it was like kind of freaked out a little bit. So eventually it came up with something. So there's code on the top, which you actually can't read if you're in the back. So you don't get to I guess you could guess it's a 50-50 chance. So, and then there's code on the bottom. And the question is, which one is, do I even remember which one? Yeah, I think I do. I want to pick you, but he hasn't seen me. Yeah? Second one is generated by the AI. No. you. Pass it down. It's covered. You're gonna get weird hand stuff on it. Cool. So we need to actually, to make our network be able to make predictions, we need to train it. And training data is a collection of inputs that also have the correct output. So for our example, we would give lots and lots of different kinds of images, and then it would say maybe 0, not a windmill, 1 is a windmill. That's what we would feed into our neural network, and that's how it would train itself. It knows at the other side when it comes all the way through, and it makes a prediction whether it was right or wrong. If it was right, it strengthens the ties that made it right. If it's wrong, it weakens them. And the way that it finds out that it calculates this is through something called a loss function. The point is to get your loss function to go as close to 0 as possible. So let's say we have a bunch of nodes. Let's say it's the alphabet. We're just showing kind of a little piece of it. And the correct next predictable letter. Actually, so what our prediction is that we really think it's going to be B, but we also think it's a good chance that it could be C or D, A, not really likely. In the real world, the actual next character should have been a B according to the training data. So the way that you calculate the loss function is that you subtract the guesses, the predictions from the actual, and then you take all of those on the right side. It's probably invisible. Then you square them. One reason is to make it so they're all positive values, but there's another reason why squaring makes more sense than absolute values. I don't remember what it is. So you take those answers and then you add them all together, and then you have essentially your loss. So if you go back and look, if you look here, if you were correct, you could see that your A would be 0, your B would be 99, your C would be 0, and your D would be 0. Then 1 minus 1 is 0, all the other ones are 0, and then it would be 0 squared, which would be 0. Add 0 together, and you would end up with 0. So that would be the ideal loss. So this is what we got. You want to try to reduce it. In this slide, I'm using a Python library called TextGenRNN. This is in a, what are they called? Jupyter Notebook on something called Google, I can't remember what it's called. Colab is what it's called, which actually lends you a GPU if you want to do any of these things. Like it's free and it runs, I think, 10 times faster in this Jupyter Notebook than it does on my computer. This is going to be running, and it will show that as every word that I never know how to pronounce correctly, epoch. Every epoch is so many fun words today. It's the whole training set being fed through the neural network, and then being fed through again and fed through again. And you can see here that the loss function is slowly, if you are in the front, I guess, you can see that the loss function on the right is heading towards 0. And depending on your training set, how many epochs you have, it keeps getting lower and lower and lower. And for example, the Rails example, I think I got it down to 0.9, and yeah. So yeah, that's the goal. You're constantly trying to bring that down. Another thing that's happening is each node has a weight to it. And a weight you could describe as like a kind of like a volume knob, where you're constantly, as you're training, kind of turning these knobs and trying to change the values so your prediction gets closer to what the real thing was. And this is essentially the neural network creating the categories for you. So you have all these nodes, they have different weights on them, they're constantly being turned. I think that this is completely unnecessary because I just said all of this, but it was fun to create. And yeah, so this here is a video of the network actually learning. You can see it being kind of from a baby to being a little bit smarter, if you're in the front. So what it's going to do is you're going to see that it starts to kind of recognize some patterns, and then it recognizes more and more patterns, and then eventually it kind of becomes something that's more realistic. So you have just a bunch of, this is what it sees first, is just a bunch of spaces. It knows about spaces. It knows that there's some letters. What the temperature is, at least with this library, it's the higher the temperature, the more it guesses. So it's actually just throwing out guesses. So sometimes it can look more realistic, but as you can see here, it just looks like a bunch of nonsense. So it's gone through, now it sees, oh, there's lots of the and these kinds of words that you see. But you also have words like sesting and sesting kind of quite a bit, which isn't a real word. And devere, which, is it a word? I don't think it is. Intor. So, and it keeps going through and learning a little bit more. And we get to the next step. You can see the loss function is reducing. And then it starts to be more like words together, and it keeps going through these steps, and it eventually becomes just utterly brilliant, as you saw from the samples, from the quiz samples. And speaking of quizzes, here's our last quiz, unfortunately. I think I only have one wafer left. So I did the same thing to the devise code base that I did to the Rails code base. I thought it might be an interesting kind of smaller, maybe less esoteric code example. This is probably absolutely invisible. They probably have a good chance. Actually, I haven't been over there. I kind of gave up on you guys earlier. Sorry. I see a hand, but we're going to see. If I see any hands over here, no one. I'm going back to you. I actually don't know which one it is. Yeah, I do. Which one is generated?
Which one is generated? Of course, the first one.
Correct? Yes. Of course. Yeah. Thank you for participating in the quizzes, people that have participated in the quizzes. So this is something that I also generated that I think is really cool. I think maybe someone should create a startup called Blogule. Git use inspatch is pretty cool too. So I came here with the idea of generating a talk and not having to write it myself. So what actually happened? Did it work? So this is the talk. Keeping Leaders Debugging Rails 5 is what it's called. It's by me. The description is the Mile Island tests things as a company by the leader. In this talk, we'll look at the world to technical company who have strategies that we can do through the most productive to the company, who communicate the code that we can do to communicate the first production of the compan. So, pretty good. I think it sounds, I would want to go to that conference. I would want to see that talk. So I think it was, 5-10 years ago or something, Snoop Dogg did a concert where he had a hologram of Tupac who rapped with him, which is just super creepy. And it's straight up Tupac. And I was thinking that what would be even better than me just generating this talk would be for me to have a hologram of myself at the conference. And I found this service where you can create something called an audio avatar. And it's really, really creepy, and I don't recommend anyone do it, because the way that it works is you sign in, and then you record a bunch of sentences that they give you to read off. The service is called Libird, but that's... maybe stay away from it. I don't know. It freaks me out. I'm probably being generated into something now. So it's you record it, and then it creates an audio avatar for you. So you can take text afterward and then feed it into it, and then it gives your voice as the voice of the thing that you just did, and it's super creepy. But so here's the talk that I generated. Imagine me as a hologram, maybe, I don't know where. Where am I? Like somewhere in the world. Maybe at Kaiji next year. And here is the talk.
The big thing that we can think of the things are experienced with a company into the same test. You know that with the best to go through the time, that's the ordering. So the problem is that if you don't want to use very simple view, then we start to think it could be able to get a lot of things. We can do with this, but it's a bit of math, which we do this is that the thing is you probably come from the scope of it. The sense in the software to the client and the team and the selfish programmer, then this is the first job is that you might see.
Don't be a selfish programmer.
The things I would like to do this problem that we're doing, and there's a lot of these values. Down to 60,000 classes or something like that, it's not the graph of you to be as a function that we want. To be good for the operation to the text that actually makes it sort the string of the backend. It is the source controllers and the thing is the same part of your data state and then it is all the code. Because I have the scope of the model and the same time to do. And the second is, yeah, we can use like this, is what I can look at like a super project.
And we all kind of want a super project in the end. This is actually kind of what some of the talks at some of the JavaScript conferences I've been to sound like. So I submitted this talk to DECON RubyConf 2019. You can see the abstract in the description. And I got an email, I think a couple weeks ago, that unfortunately, we're sorry to tell you that your talk was not accepted to DECON RubyConf. And I was pretty sad about it. I thought that this might be my chance to it would be finally my chance. But I also got an email soon after that said, hey, this talk was accepted at DECON RubyConf 2019. So I don't know if that's meta or not meta or whatever. But thank you, and I hope you have a nice evening time and party or whatever's happening. And
yeah, in short, couple of questions. Do we have? Okay, that one, yeah, please.
There's no more wafers. So you don't have to ask questions.
Hi.
Oh, shit, where? Oh,
Thanks for waffle.
Hi.
What is your, how should I say it? What is your estimate for time in future when AI can really produce working code, so we all will be unemployed? Something like that. Can you? What do you think about this situation?
I don't know. I don't think it's something that
creepy future.
I don't think it's something that we need to worry about. Like, at least for the, like to write. I don't know. Like it's such a shit show in most companies that like all the feature development and the process and everything that like I don't know if computers would. Yeah, even if it could do a better job.
But you show us a code. I saw it.
It's true. It's true. Yes. It got guessed as being the real code too. So I'm quite proud of that of that happening. I don't know. Like, I don't like to make predictions. Okay. I was following crypto for a bit, so I don't make predictions anymore.
Yeah. Thank you. Anyone else? Thank you again, Aaron.